Right, well, hopefully everyone can see my screen. I can't see you anymore, so I'm hoping that I'm not just going to be talking to myself. Welcome, everyone, and thank you for joining me. My name's Ed, as we've established, and this is my talk about Android security. In particular, we're going to focus on how not to get stung by OWASP. And the aim of this talk is to kind of give an introduction, especially to people that are new to Android, around some of the common sort of security pitfalls, and kind of an introduction on how we can fix those. So, of course, there's my welcome slide. Who am I? I'm a senior Android dev at ASOS. I'm also a dog dad and a security enthusiast, which you should definitely read as not being an expert. So whilst what you will see in my talk today is definitely relevant to the Android platform, I'm not a security expert in general, so do take it with a pinch of salt and seek advice if you do have any sort of really, massive security concerns. Again, you can find me on social. My username is, as we've just said, is spaghetti code, and I've bought a new web domain, spaghetti.dev. Please do check out that link. There's a lot of relevant content on this talk on there already. So let's cover what I'm hoping to, talk through in this talk. The first thing we will hopefully cover is an introduction to some of what is called the OWASP top 10. We'll talk more about that in a second. The second thing is that we will hopefully address the most common mistakes in our apps. We will begin to look into how we can secure our data within Room and, shared preferences as well. At the end, hopefully, there'll be time for question and answers. And as a bonus, if we do have time, I can tell you the story about the time I was stung by 50 wasps in real life. Yeah, that's a painful memory. So let's. I hope we run out of time. With a security talk, I have to kind of give a mandatory legal warning, which is a bit weird. I don't think anybody else's talk today will have one of these. But please note that anything you learn today should be used for educational purposes only. Obviously, when we look at security, there are ways of hacking and other sort of exploits that we will talk about that can be used maliciously. Please don't do that. Additionally, do not test anything on apps that you are not authorized to use. So no downloading Facebook and taking that apart, unless of course you work at Facebook, in which case that's fine. Please consider seeking your company's security advice from someone that knows a lot more than me. I've only taken recently a deep dive into security, so this is all relatively new to me. So there may be little bits that are slightly wrong. And again, if there are any sort of major concerns, please seek an expert. And of course, this talk is not associated or endorsed by OWASP or my employer. So I think after all of that mandatory legal stuff, we have one kind of burning question. Why should we care about security? And when I say we, I mean mobile developers. Well, I think the first kind of major point of why we should care is that the mobile attack surface is huge and growing. If you think of the number of devices out there, Android and iOS, the numbers have exploded. I think in the UK, I think it's upwards of 70% of the UK population are smartphone users. And that number will vary, depending where you are in the world. But, consistently in developed countries, that number can range between 60 and 80%. So the surface for attack is huge. I think most people will probably be aware that mobile security is an often neglected kind of research by organizations and developers alike. So it's really important that we should have a security mindset when we're writing our code. Kind of as we move into this new, I don't want to use the buzz term Web3, but I will. As we move into this sort of new Web3 world, there are more growing financial incentives for malicious actors to take apart your apps and or exploit your device, and that's really concerning. And I think that's definitely a reason why we should continue to care about security. The best part is that mobile security isn't really rocket science. I'm hoping that we go through some of these slides and we learn something, and you'll see actually how easy it is to fix some of the real, major issues that you may face in your app. And finally, actually, when I started writing this talk, the Log4Shell exploit was the thing in the news. If you have not heard about Log4Shell, then you've been living under a rock. It was probably one of the largest exploits that we've seen and not necessarily in mobile development, but in development in general, in the last 5 years. So there is always a risk that mobile's own version of that is always right around the corner. So that is why we should definitely care about security going forwards. In fact, there's actually a really nice quote that I found whilst writing these slides from a guy called Stefan Napo. And it says, it takes years to build a reputation and a few minutes of a cyber incident to ruin it. And I think that kind of encapsulates why we should care about security. So moving on, I think we should start to introduce OWASP. Who or what is OWASP? Well, OWASP is a acronym for the Open Web Application Security Project, and they're a non-profit organization that was created in 2001. They are a group of security experts that provide free security resources for developers. They also provide it for organizations and have numerous chapters around the world. What they are kind of famous for is for creating top 10 lists of the greatest security threats to application security. So if you go on the OWASP website, you will find top 10 lists documenting all of the sort of top 10 risks in different areas of computer science and application security. Obviously, we are mainly concerned with the top 10 mobile threats. The source is available on the screen now. I definitely recommend that you check this out for yourself. But one thing to note is that this was actually last updated in 2016. So in OWASP's mind, nothing has really changed in the last 6 years. And I think that's really, really important to note. So what are the top 10? Let's run through the top 5. So the top 5 are improper platform usage, insecure data storage, insecure communication, insecure authentication, and insufficient cryptography. Numbers 6 to 10, insecure authorization, client code quality, code tampering, reverse engineering, and extraneous functionality. Now, there's quite a lot of words in there, and I don't think we're really going to have time to cover all 10. So I am going to cheat a little bit and do the top 5. So the top 5, again, improper platform usage, insecure data storage, insecure communication, insecure authentication, and insufficient cryptography. We will go through each one of these 5 in some level of detail. And without further ado, let's take a look at the first one. And the first one is, as we've just seen, improper platform usage, which I think is a bit vague. And with all of these, I've kind of got a slide that's going to give you a good idea of what this actually means. So when OWASP says the number 1 threat is improper platform usage, what they actually mean is it's you. You are the problem. So when I say you, I mean misuse of Android features by you, the developer. Now, Android features can mean a broad range of things here. Some common features that are misused are intents, the Android keychain, general app security features. And again, this basically is any time that you use the Android framework and mess it up. Let's actually look at a live example. I've created a companion app to go with this talk. The source is available at the bottom of the screen in green. Please do check it out. I would recommend you probably check it out after the talk, but feel free to have a look and play along as you go. The app is a very basic app. Please do not, again, I'm called Spaghetti Code for a reason. It probably isn't the greatest well-written app, but please do check it out. And it's a very simple app that has 2 main functionalities. It has a screen where you can log in using a PIN. So as you can see here, it's got 4 buttons. And when we run this and enter a PIN, hopefully it's playing on screen, you can see a new activity that you can only see if you're logged in, or so we think. So why is this app vulnerable? Well, when we look at the Android manifest file for this app, there is a mistake. Now, I'm going to give you 5 or 10 seconds to have a look at this code and see if you can find what the mistake is just by looking at it. So everyone take a look and see if you can find it. We'll do a quick countdown. 5, 4, 3, 2, 1. Well done if you got it. The answer is the main activity is exported. Now, what we mean by exported is that the platform allows for activities, broadcast receivers, content providers, and services to be exposed to other apps within the device. And to do that, these activities and other components have to be exported. when you export, again, this gives access pretty much free roam for any application to access it. But on the face of it, how would we know this in the app? How would you download my app from the Play Store and say, oh, okay, well, that's exploitable? Well, that's actually quite easy to do. There are tools online, command line tools such as Droza, that scan app for vulnerabilities in activities, broadcast receivers, and content providers, and simply return a list of available kind of exploits and sort of different vectors that the malicious actor can use. Again, this is freely available online. It's a good security tool. I would recommend using it on your own apps to see if you have any kind of vulnerabilities there. But it is as straightforward as literally running a ADB command to then open up the second activity, which we can display here. It's the command is on screen, and as you can see, I bypassed the pin screen just by running an ADB command. This all seems a little bit scary, but in fact, it's super straightforward to protect against. It's as simple as marking anything that you don't want to be exported as false. I think one real pitfall that I failed to actually put in the slides and wish I had was that many people, especially when they start Android development, aren't aware of really what some of these properties do. Another kind of thing, another side effect that might not be obvious to the without reading the documentation in detail, is that by adding an intent filter to an activity or a service or broadcast receiver, you actually by default make that component exportable, which may have unintended sort of consequences. Although admittedly, I think the most time you'll be adding an intent filter, you should be expecting your component to be exported. The good news is that when you start targeting Android 12, the SDK will actually now, I think, produce a compile time warning, or it may even be an error that explicitly makes you define the exported status for your activities, broadcast receivers, services, and content providers. So this problem has been around for quite a long time. It has been actively exploited, but the good news is that Android is slowly locking that down. Another good example that I like to use with improper platform usage is something called tapjacking. Now, on the face of it, tapjacking, you might not really understand what that means. Well, it comes from, I guess, the kind of hybrid word of tapping and hijacking. And that kind of explains exactly what it does. It's a malicious app on your phone that will hijack the touch events for your application and potentially run some malicious activity. And this is done mainly because now apps can draw over other apps and monitor their contents. This has been around for a little while in Android. And this is perfectly normal. You may use this if you use Facebook and you use the Messenger app. The little bubble on screen is an example of the Messenger app using this functionality to draw over other apps and allow sort of accept touch events. If you click the bubble, obviously it will open your chat. But they can also pass spoof touch events, which is slightly more scary. And because they can monitor the underlying app that they overlay, this can actually be used to maliciously trick users into entering passwords, accepting permissions, and doing a whole lot more. Permission is now required for these apps, but that has only happened relatively recently. I found a really good video online I'd like to share. This actually was patched quite a while ago in December 2017. But when this exploit was found, what it allowed people to do was actually even bypass the need for permission. So if I play this video now, you can see that there's an app overlaying the dialer, and it presses the dialer as if the user was pressing the dialer. So whilst this is a really straightforward and simple example, it kind of shows what sort of exploits have been actively sort of used in the past and what could be used again in future without proper protection. And the last point here says this could have happened silently, and that's the scary thing, is that this could have happened without your knowledge totally at all. It was only this sample app that had the kindness to show that it was actually what it was doing and pressing buttons. Simply, this can be fixed quite easily if you have critical components in your app that should not be vulnerable to tapjacking. You can add the Android property filter touches when obscured and set that to true, and that does exactly what it says. It filters the touches when that button or view is obscured. Let's move on. I'm very aware that I have got to get through 5 of these, so apologies that we were skipping through them a little bit quickly. The second threat from OWASP that is deemed that high up in the list is insecure data storage, and I think this one's pretty clear what it is. It's your data. So let's think about some of the ways we can store data in the apps. In our apps, we traditionally may use shared preferences. Now, this is shared preferences is a double-edged sword. Whilst it is probably one of the easiest APIs to use, it also stores the data in key value pairs in plain text XML. It stores this on the device, and it is super trivial to access. You should never, ever, ever store any data that you don't want read in shared preferences. Shared preferences is there for quick access for things that aren't, super secure and critical. So please make sure that you use it correctly. We can also use room databases. Room databases are SQL-like databases. By default, they have no form of encryption. And again, they are quite trivial to access the stored data. So in these 2 examples, which are probably the most common examples of storing data in your apps, they are both not really suited for storing critical secure data. These are Let's talk about maybe how we exploit this. It's very easy to reverse engineer an app to make it debuggable. You can decompile an app using APK tool and recompile it with the debuggable flag set on. And unless you have some protection in there, it's quite easy to make your app in a debuggable state. Of course, it wouldn't be a security talk without talking about rooted phones. I mean, rooted phones have root. There's very little we can do, and I've kind of signified that with a can of worms. The XML file for your shared preferences is stored in a well-known place. It's super easy to find. You can literally just find it in your data folder under your package name, and there's a nice shared preferences folder there where you can pull all of the data. And finally, the databases are also easy to find. They're in the same place, but under the databases. And this is how easy it is to access this data. This is the sample app that I linked previously. And when you open it, you can literally just pull the shared preferences from there. We are storing secure information in that test app, but you should definitely not do that. And whilst I'm kind of presenting a lot of problems here, it'd be really nice to present a solution to this. And thankfully, the Android team have slowly started to roll out solutions to this. The first one is the Jetpack security library, which I think is now in a 1.0 stable release and has been around for a little while now. The link is on screen. I recommend that you check it out. And what it provides is an encrypted shared preferences. It does that by utilizing a secure library called Tink that is Google's kind of answer to cryptography. The one problem we have with cryptography is that everybody tries to roll their own solution, and that is inherently flawed because 9 times out of 10, we are developers and not cryptographers. Thankfully, Google has taken that on, and it has provided this Tink security library that makes sure that all of the algorithms used are the most secure and kind of doesn't allow you to perform insecure cryptography. Again, yes, I said this is currently in 1.0 stable and has been for a while. Unfortunately, it has also been stuck in 1.1 alpha for a little while. But the good news with the 1.1 release is that it provides more support for APIs. I believe that the version 1 stable is API 23, and version 1.1 now gives support for API 21, which is fantastic. And it's really easy to use. The encrypted shared preferences migration is as simple as providing a sort of a new constructor to create your shared preferences. It is pretty much like for like. The only addition here is that you can specify specific algorithms. So in this case, the constructor for this takes the application context, it takes the name of your shared preferences file, it takes a master key builder, which builds this sort of secure key that is stored within the phone's secure enclave. And it also provides a preference key encryption and preference value encryption scheme. So in theory, you could have preference keys with different particular encryptions there. So I highly recommend that if you are using shared preferences, that you consider using encrypted shared preferences, even if there's a little smidgen of data that might be useful to somebody externally. You may well want to use this solution. It's mega easy to download, and the security library for me has been, I think, a really nice introduction. But if you are a bit like me and you don't tend to use shared preferences and you tend to store a lot more data, you may want to use Room. And the problem with Room at the moment is there is no secure there is no security option with Room. You don't have any sort of option of adding encryption by default. But however, in the SQL-like community, there is a well-known solution for this, and it's called SQL Cipher. And SQL Cipher, I think, has been around for many, many years and has just recently added support for Room. The link, again, is on screen. And what it does is it provides a custom support SQL-like open helper that actually allows the implementation of 256-bit AES encryption. What this does is essentially allows users to be able to unlock the database through a passphrase. So a good example may be a banking app. Actually, in a real-world scenario, this is an app I wrote, took a list of your bank transactions and stored it locally on the device for caching purposes. And we used a sort of a passphrase PIN to be able to access the app and unlock the database to be able to show users those transactions. And that's, I think, a really good example of how to use this. And it is, again, super straightforward to implement. SQL Cipher provides the factory, and it's as simple as adding this open helper factory to your Room setup. So this can be done through dependency injection quite trivially. And as you can see, it's only 3 lines to get this to get this in your app. And I highly recommend, again, looking into SQL Cipher if you need a secure data storage solution for Room. In this slide, I've kind of put together a bit of a cheat sheet of what kind of available options we have out there at the moment. I've included Realm here. I did forget to include Data Store, although as far as I'm aware, Data Store is relatively new anyway and doesn't have, at the time of writing, any kind of support for encryption. I did find a open source project where somebody has added Tink and encryption into Data Store, but there is no first-party support for encryption at this stage. As you can see here, there are a number of plus and minuses when it comes to each of these libraries. Shared preferences, I think, has the benefit of being around the longest, but has probably the biggest disadvantage in that it, doesn't provide any encryption functionality at all. Room, again, generally, if you aren't writing secure apps, then Room is probably an absolutely fine solution. As is Realm, although Realm, I think, has a slightly higher minimum API. It does also provide an encryption functionality, but I think you sort of have to roll it yourself, which isn't great. And then obviously you have the 2 kind of new kids in town, the encryption shared preferences and SQL Cipher. As I said before, the minimum SDK for these have been around for the minimum SDK has started off at 23 and it's now gone down to 21 in encryption shared preferences. And SQL Cipher can support all the way back to API 16, which is still pretty good. Let's move on to number 3. Number 3 is insecure communication, which in plain speak is it's your networking. I think the most common cause of bugs here in networking is having a misconfigured network security configuration file. Now, that's the XML file that you have in your app, which states your network configuration. Sometimes we will make an allowance for clear text traffic. Let's say that we are using an API that hasn't yet migrated to HTTPS, which, believe it or not, I'm sure there will be people in the audience that have that problem. It also allows you to add user certificates. So if you want to do logging, or you want to do sort of interception proxying of your app through something such as Charles, then allowing a user certificate is something that we can do through the security configuration. And believe it or not, people accidentally leave it in the production version of their security configuration. It happens all the time, and that's a real problem. Another kind of aspect of insecure communication that we often forget about is our logging. I've had apps on my phone when I've plugged my phone into Android Studio where I've seen the full network traffic of an application print out in a production version of the app. Please don't do that. That is really insecure and not a good idea. And finally, if sometimes we forget to do certificate pinning and certificate transparency, although that is a little bit overkill. And hopefully, if you are aware of what certificate pinning and certificate transparency are, then you know that you probably it's only certain situations where that might be worth implementing. So let's talk about how we might exploit insecure communication. Well, as I've just mentioned, using tools such as Charles, if the user has user certificates enabled, it is trivial to be able to read SSL transmitted communications. Again, if you allow for plain text, you can read plain text from the device with ease. Things like Charles allow for breakpoints that can modify requests. So in theory, there's a chance here for privilege escalation or for spoofing. And yeah, basically, where possible, try to avoid allowing this sort of functionality in production. And the way we would tend to do that is ensuring that clear text is turned off for the base config. Again, as I say, this is not the default behavior until Android 9. So please make sure that your clear text traffic is disabled. Otherwise, you may be allowing your app to send HTTP requests, which is going to give you a bad time. And secondly, please only ensure that your debug overrides uses the user certificate, because if you don't use debug overrides and this is part of your main config, then what will happen is that the users are able to read your traffic again. So I appreciate that this one I've kind of flown through a bit. The companion app that I've written has a kind of a branch for each one of these. I do recommend that you check this out after the talk. The fourth threat that we will look at is called insecure authentication. And this one I think is, again, pretty self-explanatory. It's your identity. So what do I mean by that? I mean, when we talk about authentication, many times in our apps, our APIs will require some authentication. But many APIs also don't use access tokens. And an access token is a way of sort of verifying that the user can communicate and be authorized for the call that it's making. The good thing about access tokens is that they can be revoked at any time. Which means that, should somebody be able to access the app and, manipulate requests, the token can be revoked by somebody and they no longer have access to that particular API. Another thing that I know that people are very guilty of, and something that I have done shamelessly in the past, is storing passwords and PINs locally. Never do this. Please never do this. Do never try and create a remember me function where you store the user's password or pins locally. And if you really do have to do that, please use some of the advice taken from my previous slides, and use some form of encryption to make sure that this is done somewhat properly. Again, I think actually the most common problem with insecure authentication is weak password policies. You'll be amazed how many apps I've used with pins where the pin to enter is only four characters or 4 numbers long. That is not secure enough. You need to rethink your password policies if that is your password policy. Please do make sure that you have at least 5 or 6 characters, and where possible, even stronger than that. And persistent authentication enabled by default. So what I mean by that, again, is the remember me functionality of an app. Sometimes that functionality, if it's provided, is actually on by default, which is definitely not the most secure way of using that. You should definitely always allow users to opt in to any sort of form of persistent authentication to avoid any sort of security incident. So again, what can we do? I think I've covered some of these. The first one is to use a revocable token in your API to make sure that this is something that the users can't or malicious actors can't use to exploit. Please don't do any authentication locally if possible. All authentication should be taking place on the back end. If you're doing authentication locally, that's usually a sign of bigger problems. PIN should be length of 5+, as I've said. And again, opt in for remember me functionality. Which brings us on to the last one. The last one is insecure cryptography, which I've kind of summarized as it's your algorithms. What do I mean by this? Well, there are such things as outdated security algorithms. Please do not use any of these on screen. SHA-1, MD5, MD4, or RC2 are all algorithms that have well-known and well-documented issues. If you are using this for any form of cryptography in your apps, then please consider migrating that immediately, because these are known to be problematic for a number of reasons. Another really common problem that developers face is not knowing the difference between encoding, hashing, and encrypting. I've put here, base 64ing something is not cryptography. What that is encoding. I'll quickly go over what all 3 are. Encoding is a reversible transformation of a data format. So you can think of that as such as text. I'm sure everybody knows some encoding when it comes to text, such as UTF. It's used to kind of preserve the usability of data. Hashing is a one-way function, and that's the idea of that is to be something that cannot be reversed, but can be used to validate integrity of data. So when you hash something, there is no way to get that original piece of information back, which is where encryption comes in. Encryption is a 2-way mathematical function, which when applied to data can be reversed, but it's designed as a secure encoding of data that preserves, I guess, the confidentiality of the data that you are encrypting. Yes, and of course, don't come up with your own solutions. I think this is my one takeaway that you should have from this is do not come up with your own cryptography solutions unless you are a cryptographer. I don't know if any cryptographers have joined. I'm sure if they have, they've got plenty to tell me. But please do not come up with your own solutions where possible. So what can we do to kind of avoid these issues? The first point I would say is to consider using Google's Tink library. I've integrated that into my sample app. Please do take a look at how that works. It provides strong cryptography for both symmetric encryption and asymmetric encryption. So symmetric encryption where only a single key is used, or asymmetric encryption where a public and private key are used. The kind of 2 recommended solutions for that are AES 256 and RSA at least 2048 now. Or ECC, which I totally forget what the acronym is there for. It's ecliptic curve, something I've completely forgotten. But ultimately, the big bonus here is to just avoid storing sensitive data locally where possible. And somehow, I don't know how I've made it, but I think that's pretty much everything. So just to recap, the top threats are you, your data, your network, your identity, and your algorithms. And that's it. Thanks for watching. Please do find me on Twitter. Again, there's so many resources at that link on my nice new domain. Please do reach out if you're interested in learning more or have knowledge to share. Again, I'm an enthusiast when it comes to security at this point, not an expert. So if you have any kind of any sort of thoughts that you'd like to raise, then please do let me know. And that's it. Questions and answers to follow. Thank you.
Okay, huzzah! That was fun. So, like, how many disclaimers did we throw in there?
Yeah, that was good. I hope everyone learned something.
Oh man, there was a lot of fun conversation also in the side where people were just kind of chatting about, I don't know, topics relevant to what you were talking about, and it was a lot of fun. So I definitely recommend it.
Yeah, I'm sure there's a lot of people that know a lot more about it than I do. Yes, no, thank you for whoever it was that said ECC's ecliptic curve cryptography. Thank you. I can't believe the last word I forgot was cryptography. I got the first two and then forgot the actual word, which was cryptography. So there you go.
Let's give everybody let's give it like 2 minutes for everybody to upvote questions and write any questions you have. Also post more messages in the conversation since it seems to be quite lively. Yeah, nice. So my head, I got distracted midway because I finally found a tooth from our puppy while he's been teething, and we've been trying to find one tooth because he keeps swallowing them. So I'm sorry, I don't mean to detract from.
It's perfect. That's perfectly okay. It's funny. When my puppy was teething, he didn't swallow all of his. We had a little box of his teeth, and I kept telling my partner, I said, that's really weird. I said, people do voodoo with that type of stuff. I don't really want to keep a box of his teeth. It was just on our kitchen windowsill, which was quite bizarre. But we eventually got rid. But yeah, they are fun, aren't they?
That's true. I hadn't actually thought through what happens after I collect them. Right now, it's like this cute concept of like, oh, he's losing his teeth. We gotta keep him. And I guess I'm kind of tied into that whole tooth fairy concept, but without giving him any money.
Yeah. No, my dogs would be rich. They have so many more teeth than we do.
Jeez, talk about great startup capital. Who needs? All right. I figure people have had enough time to start. For us to start questions. So yeah, you just start saying which question you wanna. Yeah, do you want to go actually rather from top voted to lowest?
Let's go top to bottom. Let's go top to bottom and see what we can do.
Sweet. All right. Most important question first.
What's the dog's name? You know what? It's really funny. I can't answer this question because we actually don't share my dog's name online. We're pretty funny about it. The one thing I can say is that if you're a Harry Potter fan and you know he's named after a type of flower. I think if you're a Harry Potter fan and you can figure that out, then yeah, you can probably figure out what my dog's name is, but we don't actively share it online. So yeah, funnily enough, it's a very straightforward question that I can't answer. So the next one, is it considered insecure to store a user's own access token for a web service, in example, in shared preferences? It's a good question. I think it really depends on the level of access that security token kind of allows. I think it's quite common for an access token to be stored in that way. If you are worried about this, then my suggestion would be simply migrate to the new encrypted shared preferences. Rather than sort of considering it to be insecure, if you are worried about anything being insecure that you store, then secure it in a secure way. Like if you store it in the encrypted shared preferences, then yeah, the problem kind of goes away. So rather than me kind of, I guess, sort of giving specific advice there, my advice would be definitely check out encrypted shared preferences. Another one from Tyler. In regards to certificate pinning, is it okay to just use certificate pinning with OKHTTP's APIs, or should we always follow Android network security config? This is a really good question. In my experience, I think I find OKHTTP's way the best. I must admit, I've only used the network security config platform one relatively recently. The good thing about OKHTTP is you kind of write it in code. So if you need specific logic to switch, it's quite easy. Whereas obviously the network security config is hard baked into your app. Obviously that allows you to do kind of, I guess, stuff with different build variants and whatnot. But in terms of I don't know. I think you should take it on a case-by-case basis. If they both do the same thing, then it's really up to your use case. But I would definitely check out certificate transparency. There was a really good talk, DroidCon, I want to say 2019, London DroidCon 2019, about certificate transparency that I would highly recommend watching. The name of the person that gave the talk completely escapes me. If they're watching, I apologize, I don't remember, but it was a really interesting talk. Definitely check that out. Tal says, some of the mobile risks from the top 10 list have been addressed by the Android OS since 2016. Are there plans from OWASP to update the list to the state of Android today? Well, that's a really good question. And yes, definitely some of the issues have been addressed. But I would say as a whole, yeah, some of them haven't. And because these, the examples I've given today are only a handful of kind of the, what comes under each one of those categories. Apologies that I can't go through all of them in more detail. I don't think the categories necessarily are still irrelevant even 6 years later. In terms of plans for them to update, I don't know. I would assume so. They did update. The last update, as we know, was 2016. I think they updated a couple of years before that, or it was in 2015. So they do update it. And it's not just Android as a whole, it's mobile as a whole. So the top 10 list will also include our colleagues in iOS. What's your favorite password? Probably Hunter123. Is that the one that is that the one with the law? I think that's the one with the law. Probably Hunter123, if that's it. If you know, you know. If you don't, then you have no idea. But if you know what that is, then you know what it is.
Well, I gotta add that I forgot to ask for username too. I mean, for God's sake, we don't want to put too much effort into trying to steal.
Yeah, no. The correct answer, my favorite password is one generated from some sort of secure password manager. How can locally stored sensitive data be exploited when only the phone's owner has access to their own phone? Well, that's a very good question, but what happens when your phone's stolen? It happens, I'm sure, quite a lot more than you think. And certainly not necessarily people that have multiple people have access to people's phones. Yeah, it's a very valid point. How can something locally stored be exploited when you are the sole user of the phone? Well, it can be, the first part is that somebody has to have access to your phone, and if you can manage to keep hold of your phone, then great, you've got no security problem. So that's fantastic. Regarding passwords, maybe the passwordless login is more secure, like email magic link on every login. Yeah, I think this is a really common approach now. I obviously, I think I personally remember, I think Monzo was the first time I ever saw this actually implemented in an app, and it worked really, really nicely. And I think this is quite a common approach now. Passwordless login is much better. There is definitely, benefits of doing that. If you have a back-end team and the sort of infrastructure to support that, then yeah, I would definitely recommend that. How to identify if a device is rooted or not? I've used root bear before, but is there a foolproof solution? Well, the answer is unfortunately probably not. There is very rarely a foolproof solution. As quickly as a solution comes out for identifying a device as being rooted, developers can easily circumvent it in one of a number of ways. I think there is a number of libraries out there that try and do check for root permissions, and there's a number of paid solutions as well. I've not tried any of them, to be perfectly honest. I don't think I've actually ever implemented a root check in any of my apps. But from what I've read online, it's very difficult to be 100% foolproof. I believe that there is some sort of Google tool out there as well that I think allows for some checking of some sort. But I don't think there's a foolproof solution, unfortunately. Is there encryption support in ObjectBox? It's a good question. I don't know. I will get back to you because I honestly, I don't remember. I think the answer is yes, but I need to double check that. Can I say a bit about number 6, authorization? I'd love to, but that might be my next talk. So I will try and hold off for now. What I am doing, though, I will say, is that I am writing a much more comprehensive blog post on each one of the top 10. I haven't done number 1 yet. I'm working on that at the moment. But once number 6 is done, I will give you a shout. Is it a security risk to have a non-default keyboards third-party for sensitive input fields like PIN password? OWASP has L2 rules for iOS, I guess, to disable keyboard extensions. Is it even possible to handle in Android devices? I haven't looked into this. I believe it is considered a security risk to have non-default keyboards. I don't know how in the Android platform you would necessarily enforce that you use a default keyboard. But there is, with any sort of third-party apps, there is always security risk. I'm sure people can create keyboards that do all sorts of malicious activities. However, I'm not sure where that would rank in the OWASP strategies of what they would recommend there. So if they recommend it for iOS, then chances are they probably recommend it for Android as well. Any good root detection libraries? I think we've covered this. There's plenty of good ones, but I don't think there's probably any perfect ones. So if I don't have a network security config section in my Android manifest, then I'm unsafe. Well, it depends. If you're not making any network connections, then no, you're absolutely fine. If you are, not necessarily. I think the defaults are. It depends on the versions that you support. So I think in the example I gave, the clear text traffic is, I think, not disabled by default on Android 9. You can rewatch the video and go back in time, but I'm pretty sure it was Android 9. Then in that particular instance, then maybe if you do send clear text traffic, you are unsafe. I'd say it's always best to have it if you can, to make sure that you apply the relevant rules. If you do talk to, and something I should have covered actually, is if you do talk to clear text traffic, if you do talk to an HTTP link, there are ways of sort of adding it to an allow list to make sure that you are only allowing certain clear text traffic to be performed. So definitely consider that if you are using clear text traffic. But guys, it's 2022. You should definitely not be using clear text traffic. Should we use mutual SSL authentication like client validate server as well, or is it overkill? I must admit, this is something that I don't know an awful lot about. I don't feel like I'm qualified to answer this. So I will, unfortunately pass this one. But hopefully maybe I'll have a better answer for you next time. What industry do you work for? Well, we've just actually recently joined in the last year. I've joined ASOS, which is a huge fashion retailer. We sell clothes all over the world. That's why I look a lot better dressed this time in this talk than I did in my first talk from Android Worldwide. So yeah, I now work in the, I guess I work in the fashion industry, which is a bit of a bizarre thing to say, but yeah, the ASOS has got a huge tech team. I see ourselves as very much a tech company as well as a fashion retailer. So yeah, I work in fashion, I guess. What do I think about login with token session? Again, probably not the best person to ask about this, unfortunately, quite yet. But I think as long as you are, as long as the session has a decent expiry, you're not expiring it in, when I say decent, I mean a relatively short-lived expiry, 24 hours or something like that, where it can be revoked relatively quickly. I think that's absolutely fine in some circumstances. If your token lasts a year and you're logged into an app for a year without any kind of other sort of session validation, then yeah, probably you need to rethink that. So in certain circumstances, maybe it's fine. Again, a lot of security kind of thing is dependent on your circumstances and your particular use case. But yeah, when it comes to kind of sessions, you want to kind of limit the sort of validity of a token for as little time as you can feasibly allow. Is it more or less secure to block copy-paste support on password fields? If you're asking me, and I think OWASP would say that blocking copy-paste support is generally speaking more secure, because it forces the user to validate the password and enter it correctly. Whereas I guess copy-pasting, in theory, I guess there are ways of sort of maliciously copying and pasting. One thing that Android has done recently, again, to address this, I think in newer versions of Android, is be a lot more explicit about what apps are currently accessing your clipboard. So I think at least in Android 12, I don't remember if it was an Android 11 feature, but in Android 12, when an app uses the pasteboard or copyboard or whatever it's called, the clipboard, that's the word I'm looking for. When they use a clipboard, I think a system toast is kind of shown to the user. So if there are any kind of malicious apps that are manipulating the clipboard, you become aware of those. But obviously that's a relatively recent addition. So older devices don't have that support. So in answer to your question, I think it would be more secure to kind of block copy and paste support in that instance. Have you ever had a security issue at work? If so, did your team handle it? Obviously, I can't go into too much detail. I'd love to tell you all about everything I do, but obviously, there is some level of confidentiality there. We have had a security issue. It was a relatively minor one. It affected a single version of an app, and how we handled it was quite straightforward. I triaged it. We kind of walked it through with our cybersecurity team, who are excellent. Discussed kind of the risk, which was really, really minimal. I think actually, it was as kind of minimal as it could have, conceivably be. And we actioned a hotfix right away to our app that fixed it. And thankfully, our app has the ability to be force pushed, so we can disable versions of an app from a specific version if that's deemed necessary. And if you are building an app, I would highly recommend that you add force push functionality in. It's probably it's the best thing you probably will hopefully never need. I think that's the best way of describing it. So if you ever need it, it's there, and if you don't, then it sits silently in the background. So yeah, definitely consider that. But yeah, our team are excellent. So yeah, it was handled really well. Do you do anything to address app cloning? Do we do anything to address app cloning? Not, I don't think there's plenty of things you can do. I don't know if I'm relatively new to the company, so I don't know the answer to that. I don't want to give a good answer to that. But what I do know is that the Jetpack security library has recently added an app authentication tool, which is I think a library that's in alpha that allows the certificate of your app to be kind of baked into an XML file that can then be verified within the app. So if the way I think it works is that you at runtime are able to kind of check the certificate of your app to check it is valid and is the one that you expect. Obviously, with app cloning, that would fail, and you'd be able to kind of stop the functionality of your app if it was kind of cloned and anything maliciously added. What are some free available tools to quick pen test an APK so someone can at least fix common vulnerabilities? I would highly recommend checking out OWASP. There is a number of good websites actually that I have totally forgotten off the top of my head. I'll try and post some on Twitter that would help out. APK tool is a very popular tool that allows for the decompiling of an APK. I'm sure there's plenty of sort of jar file viewers out there that people use that might be also useful for sort of pen testing. I did link I think in the talk there was a couple of ones, Droza, and I think there is also an additional one called Splice that can be used to take apart an APK and provide sort of vectors for attack. You can definitely do a good Google search of this. I did a Google search whilst researching this, and there was plenty. So I'll try and list them out, and certainly in upcoming blog posts, I'll make sure that I add some of these. But thank you, good question. Are zero knowledge proofs used or might be used in future for encryption authentication? I don't know if I know what that means, so I'll pass, I'm afraid. Again, I'm not a security expert. I'm afraid I'm only an enthusiast that's just joined. In your opinion, how better way to handle with certificate pinning beyond a trust manager or certificate pinner? I think I genuinely would. Again, I think this is a similar answer to what I gave earlier. I think consider looking into certificate transparency. It's slightly easier to use. I think there's a Babylon Health open source library that allows certificate pinning, certificate transparency. That's well worth looking into. When it comes to what's the better way to handle certificate pinning, I have relatively limited exposure to that, so I wouldn't be best probably to give you a good answer for that. What can be done for apps that are using SSL pinning as well as proxy detection, but still need to be run in a safe corporate environment? And you're not the owner of those apps, so you can modify the network configuration to allow user certificate. Wow, there's quite a lot to unpick in that one. Let me think. What can be done for apps using SSL pinning as well as proxy detection? I'll be honest, I'm not really sure how to answer that one. Again, maybe I can look into that and get back to you. There's a lot of questions. I was expecting there to be. I'm not sure if that's a good sign or not. There have been exploits related to how Android natively decodes media files. Is this something we as app developers can do to minimize this risk from such attacks in our app? It's a good question. I think that possibly falls into another part of the OWASP top 10. So it's not one that I've, again, kind of looked in detail. So I think there are definitely things you can do, but off the top of my head, I don't know what those are.
You can breathe. That's the end of it.
Wow. Well, thank you so much for having me. I've really enjoyed it. I'm sorry that I couldn't answer all your questions. Again, I've only recently dived into security, so I'm sure there's people in the audience that know a hell of a lot more than me and could have done my talk a lot better. But thank you for joining me anyway. I really appreciate it.
I call first. No, nobody could do this better than you, Ed. You're the only Ed. No, this was an excellent talk. It was, I think a lot of us found it interesting. It kind of was off the beaten path from the regular Android conversations, where it's typically like very, I don't know, it feels more Android-y. Yours didn't feel particularly Android-y. It was kind of more like a lot of it could be information you apply if you were to go over to iOS. If you honestly like on any mobile client, and even carried over to probably even some of it to web client.
Yeah, absolutely, and that's kind of the whole purpose, is that the OWASP top 10 is platform agnostic. You know, I'm hoping that, you know, some of what I've talked about today, you will be able to take to your colleagues in iOS and say, oh, hey, I heard about this. Is this something that affects you? And, you know, it's again, I think that I'm hoping in this coming year to put out more content that, again, will be slightly, it will be Android focused, but again, agnostic enough that hopefully, you know, should, you know, be applicable to most people. So we shall see.
Nice. All right. So this concludes the second talk by Ed for Android Worldwide. Please give opinions on whether you prefer him with or without a hat, because that's probably the most important.
I prefer me with a hat today. Trust me. We had this conversation before I started. My hair is just outrageous at the moment. So hat stays today.
I mean, that's kind of harsh for you to be saying that, given how I currently look, because there's a lockdown and no way for me to get my beard trimmed. But okay, Ed, you know what?
Should have gone with the hat. Should have gone with the hat.
I should have. I should have. I have a DroidCon Boston toque that I should have worn. Or I think toque's not a word for anybody outside of Canada. That means what Ed's wearing, which I think other people call a hat. I hear toque's only a Canadian thing.
Yeah, it's not. It's not a UK thing. So
yeah.
Presumably it's a Canadian thing.
Okay, yeah. All right, glad I clarified. All right, guys. Well, take care. See you soon.
Take care, everyone. Thank you for having me.